Okay, if you can write that down, we'll get started. Electric fields. No fighting with Siba. She's very weak. She had no breakfast. She would fall over. Right, you got this? Electric fields? Oh no, you're okay. You have your chocolate biscuits, huh? Are they still on sale in Tesco? €2? Nice. Nice. Okay, electric fields. So there's a little bit to do. This is something I think you would have done in chemistry, right? Or maybe not. I don't know if you can tell me. Have you talked about electric charge in chemistry? So what do you know about electric charge in chemistry? What about them? What type of charge? Negative charge, yeah. And what else carries charge? Yeah, and what charge does it carry? Okay. A neutron? What about it? No charge. So, electric charge is a basic property of electrons, protons, and other particles. Now, I don't know if you know of any other particles with a charge. The two that you learn about in chemistry are protons and electrons. That's the two we'll care about as well. Electrons are negatively charged, while protons are positively charged. Okay, so that's the first thing anyway, so you just want to make note of this. Can I give you 50 cents and take it back? Because I'm so hungry. But I don't want to just take it off you. No, please, because I'll feel bad if you don't. How many's in the pack? 4 of these? Oh, good, you made a profit then. That's okay, I don't mind. Thank you, I'm so hungry. I'm so hungry. Oh wait, hang on, no, did you have some? You ate yours, didn't you? Oh goodness, no. I'm not going to eat your breakfast. That'd be terrible. Yeah, but you're talking about to eat. You had breakfast? I know, I'll let you have it, it's okay. That's fine. No, it's okay, it's okay. I'll feel so bad. Like, what if you faint because you didn't have enough food? That'd be so sad. What class have you got after mine? What class is after this? Oh, you'll need all your energy for chemistry. All your energy. Alright, if you can write that down. I'll just have to be strong until lunchtime.
I have some toast.
That's okay. No, it's okay. I shouldn't be such a baby. I'm such a big baby. If you can write that down, we'll continue then. You got that? Yeah. Yeah, you got that? Yeah, okay. Continuing. Now, you probably also know this from chemistry. Things that are negatively charged and things that are positively charged, they pull on each other. And what happens if they have the same charge? Repel. They push away. Oh, by the way, this is what helps the electron stick to the proton, because electron is negative and proton is positive. So, things that have the same charge push each other away. So, what was the word, Siba, you said? Repel, yeah. They repel each other. This is called the law of charges. It's very basic, you know this. You probably learned this in middle school, right? Baby school. But at least write the name down, law of charges. Andak told me he's sick today. Poor guy. He always looks so sick in class recently. Right? Right? I feel bad for him. Like for the last, I don't know, 6 weeks, I think he looked sick. Yeah. For 6 weeks? Yeah. You shouldn't laugh at him, it's sad. You should have sympathy for him. Don't worry, Andek, if you're watching this later. I'm concerned for you. Your classmates aren't. Okay, you got that? Yeah. Law of charges. Are you writing the whole thing down, Gao? Okay. We're just waiting for Gao. He wants to write the whole thing down. That's good. That's good. Okay, continue? No. That's no problem. They don't mind. They're having breakfast. They're taking it easy. Do you have breakfast, Matt? Good for you. A good breakfast? Tasty breakfast. Chocolate muffins? Very tasty breakfast. Okay, continue. Great. Now, an electric field. So this is a new idea. An electric field is a vector field. Now, before we even continue, I have to explain what a vector field is. So I'll draw this with a picture. Here's an example of a vector field. So imagine there's somebody here, and then here's a wall, and you have some wind. You understand who will feel more force from the wind, A or B, if the wind is blowing from here? B, why? Well, because A has a wall. So we can kind of picture the force from the wind. It's different in different places. So here's the force of the wind here. Here it is here. But then what happens here? Maybe it hits the wall. So it's not the same everywhere. Here and here they have different forces. This here, what I drew just here, this picture, this diagram is called a vector field. That's what this is called. This here, it's called a vector field. Okay, you know this word field, like outside. So that's, you know, it looks like a field full of vectors. So that's what I mean when I say here a vector field. So an electric field is a type of vector field. It shows the direction that a very small positive charge particle will move when placed in the field. So I give you, go back to my picture, okay? Imagine I draw a field like this, an electric field. What this tells me is if I put a small positive charge here, it will move this way. If I put it here, it will move this way. If I put it here, it will move this way. It tells me where the small positive charge will move. That's what the electric field is. It's a way of seeing how a small positive charge will move. Okay, so you need to write this down carefully. And if you like, you can draw some pictures to help remind you of what it means. You got that? You probably didn't do this in chemistry, right? I don't think so. Well, no, probably not. Okay. Right, now, here is an example of an electric field. Now you don't have to draw this because I'll do this again later. I just want to give you a picture to look at. So, this picture makes sense. If I put a small positive particle here, it will move this way. Why? Well, because this one is negative. If I put a small positive particle here, it'll move out this way. Why? Because this one here is positive. It's the law of charges. If I put it here, it'll move to the left because this guy's negative and this guy pushes it, repels it. Okay? So this here is an example of an electric field. The electric field around for example, a proton and an electron maybe. Something like this. Now we'll actually... No. Tell me, did you draw any pictures with this definition? You drew no pictures. Okay, well then in that case, I want you to draw this picture with your definition as an example. So just write an example of an electric field. Got that? Yeah? Everybody drew that, Matt? Okay. Right. Now, how do we measure charge? We use a unit called Coulomb to measure charge. We actually, I think we talked about this in electricity, did we? Can't actually, yeah, we did. So the Coulomb C is an SI unit for electric charge. And the definition is, it's the charge, well, I wonder if you can remember, it's the charge when you have a current of 1 amp for 1 second. And the reason for that is the formula. Do you remember Q equals IT? So if you have 1 amp for 1 second, then you'll get 1 coulomb of charge that comes out. Okay. That definition, they ask that in the exam quite often, you know, maybe 20% of the time. So it's not a difficult definition, it's a good one to know. So if you can write that down, please, it's the you just need the second sentence. It's the charge transported by a current of 1 amp in 1 second. I think today is definitely chicken shawarma day. Definitely. Now, I'm just wondering, is it chicken shawarma and cake? Or just chicken shawarma? Haven't decided yet. Have you tried their shawarma?
Where?
At the traffic lights.
The
Yeah. The corner, yeah.
Yeah, I think I have.
Yeah. Oh, by the way, I forgot to ask you, how was the active listening? Too fast, too slow, too easy, too hard? You were okay with it? Okay. Just okay. Did you think about what questions to ask? Don't you have to write up 3 questions? Did you think of them yet? It's for Wednesday, is it?
Yeah.
Yeah. So you'll think of them on Tuesday then. Yeah. Alright. Okay, so what is the charge of a proton? The charge of a proton is quite small. It's 1.602 times 10 to the minus 19 coulombs. I don't think you did that in chemistry. Did you do this in chemistry? I don't think you do this, right? You don't use coulombs in chemistry. No. Yeah? Yeah. Continue?
It's minus 19.
Yeah, minus 19, yeah. Yeah, it's very small. So then, charge of electron, this should not surprise you. It's the same except for a minus. Right? That's not surprising. Yeah, it's okay. And what's the charge of a neutron? 0 coulombs. So, by the way, the mass, you might need to know this for the questions. The mass of a proton is a rather small 1.67 times 10 to the minus 27. An electron is even smaller, 9.11, 10 to the minus 31. And finally, the neutron is the same as the proton in mass. Got all that? Yeah. Continue? Yeah? Yeah? Okay, good. Right. Often the full value of E is full value of the charge is written as just E, which is actually on your calculator. It's one of the constants on your calculator. Not that calculator, I'm sorry. Not that one. That one. It's different to the E in maths class, okay? It's a different E. Okay. This is also in the formula book, this constant. Okay, continuing, so. Continue, go? Yes. Not go, Chow. I'm confusing you because I have another Chinese student called Gao. In January. Yeah, Gao and Chow. Very similar. Okay. Different parts of the field will be stronger and other parts will be weaker. So if I go back to the picture here for a second, where do you think it's the strongest? Where do you think the most force will be on the small little positive particle? So what about here? A lot of force or a little force? Here. A little force. Now what happens if I put it here instead? Be more force, okay? I think the strongest might be somewhere here because it'll be pushed to the left because it'll be repelled here and it'll be attracted to the left as well. So I think the force might be strongest like here. So we need to talk about a formula now. Different parts of the fields will be stronger or weaker. After all, shouldn't a small positive charge fly away faster if it's nearer to a large positive charge? So imagine you have a big positive charge and a small positive charge. If I put it here, it'll just move away slowly. But if I put it here, it will shoot away. Okay? This gives us the idea of what's called electric field strength. It's how strong the field is. So the electric field strength, called E, is defined as the force per charge. So as a formula, it's force divided by charge. And the units, of course, are newtons per coulomb. Got that? Yeah? Yeah? Continue? No. Continue, yeah.
I see.
Yep, continue. Okay. Next now. So here's our first question. A current running through an uninsulated copper wire produces an electric field which has a strength of 10 to the minus 25 newtons per coulomb a distance away from the wire. What is the force felt on a free electron at this distance from the wire? So I'll just draw that for you and you can draw it too. So you have a copper wire. And this copper wire produces an electric field. And it has this much strength some distance away. I don't know what the distance is, I'll just say here. The electric field strength is 10 to the minus 25 newtons per coulomb. And then what I do is I put a little electric charge here. And it will experience a force. And to calculate that force, I just have to use the formula E equals F over Q. So, what's the F here? It's equal to EQ. Do we know the E? We do. And do we know the Q? We do. I gave it to you earlier. What's the charge of an electron? It's 1.67, is it? 1.602 times 10 to the minus 11. Oh, japers, 19. Okay. Right, and then that's just it. That's the answer. So if you want to calculate that. Yeah? Thanks. Chow, what is it? 1.602 newtons. Oh, yeah. Newtons. Okay, continue. Oh. You said 34, didn't you? They say 44. I think they're right. 44. Continue? Yes, guys? Yep. Okay. An electron is placed a distance from 3 protons. The 3 protons produce an electric field. The strength of the field is that. what is the acceleration of the electron? So I'll just draw the picture for you and I'll let you try it first before I do it. You have 3 protons and they produce an electric field. And then here you put an electron, 1 electron, isn't it? Yeah. And here the strength of the field is 1.41 times 10 to the minus 24 newtons per coulomb. Which way will the electron move? In or out? In. It'll move in. Okay. My question, I think you can do this, is what is the acceleration of the electron? Its acceleration. It's going to move towards the 3 protons, isn't it? It'll move this way. I want to know its acceleration. Can you try and calculate that? I think you can do it. And then I'll do it. Got that? Got an answer? I think it'll be a pretty big answer. What did you get, Matt? Oh, small answer, okay. What was your answer?
2.48 times 10 to the power 13.
Pretty small. What did you get, Kim?
2.48 times 10 to the minus 13.
Okay. So, I think you probably all did it this way. Newton said F equals ma, and we also have E equals F over Q. So you can say A equals F over M, which equals EQ over M, which equals 1.41 times 10 to the minus 24 times, what was it for the electron? 1.602 times 10 to the minus 19, then all over 9.11 times 10 to the minus 34? 31. Okay, so what do you get here? You got 2.48 times 10 to the minus 13 meters per second squared. Is that okay, Siba? Are you sure? Did you get this or not? What happened? Oh, okay. Okay, continue. Did you write it down? Yep. Chow, continue. Yep, okay. Right, next example. A small dust particle of mass 1 milligram and charge of minus 100 E is placed between two horizontal plates. The plates produce an electric field. The small charge is held balanced between the two plates and does not fall. How strong is the field? So I'll draw the picture here. You have two plates. Oh, good grief. Two plates. And you have a small negative charge here. Okay? And this guy here must be positive. And this one here must be negative. And here's the field. And do we know the strength? We don't know. All we know is that the mass is 1 milligram. So that's 10 to the minus 3 grams, which is 10 to the minus 6 kilograms. Okay? And we also know its charge is minus 100 E. And the E is the charge of an electron. I gave it to you earlier. So my question is, what is the electric field strength? And my tip is, you know, there's one force here. What's this force? It's the weight. So if this is balanced and not moving, then the force up here from the electric field, it must cancel that. So you must have F equals W. And now you can work out the E. I'll let you try it. See if you can get it. Then I'll do it. See if you can figure out what the E is. Sure. I go back to the picture, Matt? I mean, I can switch to this. Yeah. Okay, will I do it now? Time to do this? Yeah? Siva, do you need a minute? Or do you get it finished? It's okay. So, F should equal W, and W equals mg. And F is equal to EQ. So you have EQ equals mg. So then that means E is equal to mg over Q, which is 10 to the minus 6, 9.81 over 100 E, which is 1.602 times 10 to the minus 13? 19. Right, so what did you get here as the answer? It's a big answer, isn't it?
6.12
Yeah.
times 10 to the
Newtons per coulomb. Yeah. Okay. Continue. Do you need a minute, Chow? Yep, no problem. 10 to the minus 19, and this is 11. Yeah, okay. Right. So this is kind of a trick question. A proton and another proton are a distance apart. What is the field strength in the middle? Shoes falling apart. Okay, so you have a proton here and a proton here, and I want to know right in the middle what's the field strength. And remember the formula E equals F over Q. Now, the answer is 0 newtons per coulomb, because if I put a small positive charge in the middle, which way will it move? Will it move left or right? No, because it's balanced, it's in the middle. It's the same distance between these protons. Okay? So there's no force acting on it, because the forces have cancelled. So the total force is 0 newtons. So the field strength in the middle here is 0. Okay, that's fine. Right. And that's that. Okay, and I have a couple of questions here. Let's see now. Let me see how many I gave you. Oh yeah, sorry. Before continuing, there's one thing left to do, which I didn't do. I didn't draw for you. So earlier you drew, I think you drew this one for me, the positive and the negative, wasn't it? So you have positive, was it, I put positive here and negative here. Oh, the other way around, was it? Okay. Alright, well, what I want to draw is, no, actually I won't draw it, because I think you can figure it out. Can you look at the last question, number 4? The only thing I'll tell you, remember, the electric field is which way a small positive charge moves. So can you look at question 4 there? Am I looking at the wrong lesson? Oh, good. I guess I'll do it in the next lesson. Fine. So the only thing you have is this little picture. Fine. Fine. Obviously that's question 1, not question 5. Yeah. So this is pretty simple. There's only one formula for it this morning. E equals F over Q. You'll get these questions finished now, and then you'll have no homework. Can you do those 5 questions now?